number 12, number 12 and 13 are exponential functions, and it's talking about growth and decay and analyzing the functions for behaviors. So let's jump into it. I do want you to sketch the graph first, so I'm going to go ahead and type it in y equals. Clear out all that stuff. And if you want to make it to where the plot is not, it's not trying to plot the points, which sometimes can create an error, you just press enter, and then it's no longer active. Okay? So 0.32 raised to the x, and then minus 3. So I'm going to go to the table, and okay. So the farthest to the left this goes is -6, and I cannot see 928, so I don't have to worry about plotting that point. Or 295, or this, but I can see at -3, 27.5, so if this is 27, somewhere in here, so 1, 2, 3, so 27.5 would be like right here. -2 is 6.8 basically, so -2 is 6.8, so here's 7, so 6.8 is like right there. 0.125 for -1, so that's really small, 0.125, and 0 is -2, and -2.68, so okay, so here's -3, so -2.68 would be in there. -2.89, so it's getting closer and closer to 3, -3, I guess I should say. And that is able to tell you what your asymptote is, okay? So my function, it's a lighter color. It should try and go through those points, but it does come down. And goes down through that one, and then go through that one, and then it kind of levels off. Okay, so what I'm going to draw below it, or kind of along with that, is this right here, and this is the horizontal asymptote. It is how much the function is approaching, and it is the vertical shift down 3. So what I'd like, let's see. Let's just draw and label the asymptote. So it is a horizontal asymptote, and that is an equation that goes through the y-axis, so it's through y equals -3. Wouldn't be a bad idea, though, to put that on the graph. And I'm going to go ahead and draw an arrow at this end as well. Okay, so let's start answering all these questions. Is it growth or is it decay? Well, going from left to right, it is going down, so this is decay. The rate, okay, so when we did exponential and exponential equations, it was a times b to the x, right? Where b is the base of the exponent. Well, so another way to write it is 1 plus or minus the rate. Okay, so the question is, 0.32 translates to what rate? So what you have to do is think about this. 0.32 to the x is equivalent to 1 minus, and then 1 minus what? So 0.32 plus what gives you 1, and that is 0.68. So that means my rate is 0.68, yeah? So I'm going to write 0.68 or 68%, okay? So it's how far away it is from 1. I knew it was minus because 0.32 was less than 1, but if it was 1.32, then I would have 1 plus 0.32. Okay, domain is how far left and right the function goes, and this function goes all the way to the left, and it goes all the way to the right. It expands in both directions forever, so -infinity to +infinity. But as far as range goes, range is up and down. The lowest it goes is -3, but it doesn't actually reach it, and then the highest it goes is infinity. Alright, in behavior. So in behavior has to do with our limits. The limit as x approaches -infinity, and the limit as x approaches +infinity. So as x goes to -infinity, the function is going up to +infinity. And as x goes to +infinity, the function is leveling off to -3. The x-intercept is where it crosses the x-axis, so I need to actually find that. So window, I'm going to graph from -6 to 6, just like this. And I'm going to go -4 to 30, just like that. Alright, I need to find the root where it crosses the x-axis, so second calculate number 2, the 0. And I need to go to the left of the root, which in this case is going to be a positive y value, press enter, and then once I go below it, which has a negative y value, then I'm good on either side of it. Press enter, and I get that the x-intercept is -0.964, 0. And then the y-intercept is where it crosses the y-axis, and I know that it crosses the y-axis at 0, -2. And I get that from, like, if x is 0, then I've got 1 times 0.32 to the 0, which is 1, so 1 minus 3 is -2. So 0, -2. You can also just find that by looking at your table, 0, -2. Okay, so the last thing is average rate of change. Your average rate of change is basically your slope. So if I ask you to find the average rate of change on -2 to 2, that means this is an interval of x. So this is my first x and this is my second x. So thinking about this, I'm just going to draw another sketch over here. So let's say here's my curve. Okay. What I want you to do is, like, say this is -2. This is the point there. And this is at +2. Well, make it, okay. When I say average rate of change, I'm actually asking you to find the slope between these 2 points. So I'm asking you to find this slope. So it is going to be a negative because you're going down and to the right. So rise over run is fall over run. But the important thing is to understand that, like, the formula for slope is just change in y over change in x. Or y2 minus y1 over x2 minus x1. Okay, so I've got my x values, I need my y values. Yeah? So I've got at -2, so let me do an x and a y. At -2, the y value is 6.7656, and at 2, the y value is -2.8976. So, x1, x2, y1, y2. So -2.8976 minus 6.7656 over x2 minus x1. And then we type that in. So if you want to do the home screen, you can just say this and type it in and then say enter and then divide by 4. Or you can do the alpha y equals and use the fraction shortcut. -2.8976 minus 6.7656 divided by 2 minus a -2. And you get -2.4158. And that is my average rate of change. Okay, number 13. That's really sweet. Just hearing, you're so stupid. Okay. And work. Okay. So go to y equals, and 4 times 1.25 raised to the x plus 2. And I'm going to go to my, I can see what it looks like, basically. Okay, so now let's go to the table. Alright, let's go to -8. Okay, and -8 is at 2.671. So 2.671. Now I'm going to keep going. When you think about what is this approaching, the horizontal asymptote, it looks like going to the left, it's getting closer and closer to 2. So I think it's safe to say that the horizontal asymptote is going to be at 2. So I'm going to go ahead and actually draw that. The horizontal asymptote at y equals 2. Okay, I'm going to go back to -8. And the reason why I did that is because this is not like super clear as to where it's headed. So I wanted to go ahead and look at that. Okay, so negative 8 is 2.67. So if that's 3, then 2.67 is somewhere in there. I'll go ahead and jump to negative 6. 3.04, so basically 3. 3.6. So put it halfway. 4.04, so basically 4. 4.56. 5.2. Oh, crap. I did not do that right. Okay. At negative 2, we're at 4.56. So actually right there. That was silly. I just started going by ones. Okay. And then at 0, we're at 6. I was about to say something does not look right. Okay. And then, let me get a different color and X those out. And then at 2, we're at 8.25. 2, we're at 8.25, so close to 8. At 4, we're at 11.8. 4, we're at 11.8. So if this is 11, 11.8 is like right there. At 6, we're at 17.3. At 6, we're at 17.3. So here's 17, so 17.3. And then at 8, we're at 25.8. 25.8 is close to 26. All right. So we're connecting them. I'm going to twist it and make it easier for me to graph. Close enough. Okay. So here's my graph. And now we need to answer all the questions. Or analyze it, I guess. Growth or decay? Well, from left to right it goes up. So this is definitely growth. So the rate is, okay, so it's 4 times 1 plus, and so 1.25 is 1 plus 0.25, so it is a growth rate of 0.25 or 25%. Domain from left to right, it goes, it spans all the way from left to right, so all real numbers. Range, the lowest it goes is 2, the horizontal asymptote, and the highest it goes is infinity. In behavior, so limit as x approaches negative infinity, and the limit as x approaches positive infinity. So when x goes to the left, where's the function going? It's getting closer and closer to 2. When x goes to the right, where's the function going? It's going up to infinity. Alright, x-intercept. X-intercept is where it crosses the x-axis, and it never does. So it never crosses this horizontal. So we'll say none. Y-intercept, it crosses the y-axis at 6, which is 4 times 1, because 1.25 to the 0, when x is 0, is 4 times 1 plus 2. So that is the 0.06. The asymptote we already said. It's a horizontal asymptote at y equals 2. And the average rate of change on this. So x1, y1. So just kidding, x2. Wow, that was bad. Alright, so I'm going to create a little table. X, y, so 0 and 2. At 0, we're at 6. And at 2, it was 8.25. Using the chart? Okay. 8.25. So the average rate of change is y2 minus y1. Y2 minus y1 over x2 minus x1. So that is 2.25 divided by 2. So 1.125. 8.25 minus 6 divided by 2, 1.125, and that is my average rate of change. And that is page 3.